Let's now continue learning important JavaScript features. And one topic that we haven't touched yet is asynchronous JavaScript. So the goal of asynchronous JavaScript is basically to deal with long-running tasks that basically run in the background. And the most common use case of asynchronous JavaScript is to fetch data from remote servers in so-called AJAX calls. And so that's what we will do in this section, while learning everything there is to learn about promises, the fetch function, async await, and error handling. So this is yet another really exciting section, and so let's get started. Let's start this section by understanding what asynchronous JavaScript actually is, and also learn about the most popular use cases of asynchronous JavaScript, which is basically to make so-called AJAX calls to APIs. Now, to understand what asynchronous JavaScript code actually is, we first need to understand what synchronous code is. So basically the opposite of asynchronous. So most of the code that we've been writing so far in the course has been synchronous code. And synchronous simply means that the code is executed line by line in the exact order of execution that we defined in our code, just like in this small example. So as the first line of code is reached in the execution, it is simply executed in the execution thread. Now don't worry about this execution thread. It's not important here. It's just to make a point of synchronous versus asynchronous code, as you will see in the next slide. All you need to know is that the execution thread is part of the execution context, which does actually execute the code in the computer's processor. But anyway, then the next line of code is executed, and then the next one, all in sequence. So each line of code always waits for the previous line to finish execution. Now, this can create problems when one line of code takes a long time to run. For example, in this current line of code, we have an alert statement which creates this alert window. Now, as we've experienced in the past, this alert window will block the code execution, right? So nothing will happen on the page until we click that OK button. And only then the code can continue executing. And so the alert statement is a perfect example of a long-running operation which blocks execution of the code. So again, only after we click OK, the window disappears and the next line can run. So this is hopefully a nice illustration of the problem with synchronous code. Now, most of the time, synchronous code is fine and makes perfect sense, but imagine that execution would have to wait, for example, for a 5-second timer to finish. That would just be terrible, right? Because meanwhile, nothing on the page would work during these 5 seconds. And so that's where asynchronous code comes into play. So this example contains the 5-second timer that I just mentioned. And if you want, you can pause the video here for a minute and analyze this code before we move on. Now, anyway, the first line of code is still synchronous here, and we also move to the second line in a synchronous way. But here we encounter the setTimeout function, which will basically start a timer in an asynchronous way. So this means that the timer will essentially run in the background without preventing the main code from executing. We also register a callback function, which will not be executed now, but only after the timer has finished running. And we have actually already done this many times before in practice, right? Now, this callback function that I just mentioned is asynchronous JavaScript. And it is asynchronous because it's only going to be executed after a task that is running in the background finishes execution. And in this case, that is the timer. So this callback that we just talked about is registered, and then we immediately move on to the next line. So the main code is not being blocked, and execution does not wait for the asynchronous timer to finish its work. And that's the big difference between synchronous and asynchronous code. So previously, we had to wait for the user to click on the alert window to continue execution. And again, that's because alert is blocking synchronous code. But now, with this timer, the callback is actually asynchronous. And so it's only going to be executed after the timer has finished. And so therefore, we say that it's non-blocking, because in the meantime, the rest of the code can keep running normally. Now, when the timer finally finishes after 5 seconds, the callback function will finally be executed as well. So you see that this callback runs after all the other code, even though in the code it doesn't appear at the end. And so basically, an action was deferred into the future here in order to make the code non-blocking. And actually, we already saw this behavior happening before when we first learned about timers. We just didn't know that this is called asynchronous and non-blocking code. So in summary, asynchronous programming is all about coordinating the behavior of our program over a certain period of time. And this is essential to understand. So asynchronous literally means not occurring at the same time. And so that's what asynchronous programming is all about. All right. Now, as we saw in this example, we need a callback function to implement this asynchronous behavior, right? However, that does not mean that callback functions automatically make code asynchronous. That is just not the case, okay? For example, the arrayMap method accepts a callback function as well, but that doesn't make the code asynchronous. Only certain functions, such as setTimeout, work in an asynchronous way. We just have to know which ones do and which ones don't. Okay? But please understand this very important fact that callback functions alone do not make code asynchronous. That's essential to keep in mind. But anyway, in order to really understand this, let's see another example. So this example is about loading an image. So the first 2 lines run in a synchronous way, one after the other. Now in the second line, we set the source attribute of the image that we selected in the first line. And this operation is actually asynchronous. So setting the source attribute of any image is essentially loading an image in the background while the rest of the code can keep running. And this makes sense, right? Imagine that it's a huge image. We wouldn't want our entire code to wait for the image to load. And that's why setting the source attribute was implemented in JavaScript in an asynchronous way. Now, once the image has finished loading, a load event will automatically be emitted by JavaScript. And so we can then listen for that event in order to act on it. Listening for the load event is exactly what we do here in the next line as well. So here we use addEventListener and register a callback function for the load event. So just like in the previous example, we provide a callback function that will be executed once the image has been loaded and not right away. Because again, all this code is non-blocking. So instead of blocking, execution moves on right to the next line immediately. Then once the image is completely loaded, it's displayed on the web page and the load event is emitted. And since we're listening for that event, our callback function is finally executed. So once more, we deferred an action into the future, making the code asynchronous and non-blocking. All right, and so now at this point, I believe that you have a pretty good understanding of asynchronous code. There is just one more important thing that I need to mention, which is the fact that event listeners alone do not make code asynchronous, just like callback functions alone do also not make code asynchronous. For example, an event listener listening for a click on a button is not doing any work in the background. It's simply waiting for a click to happen, but it's not doing anything. And so there's no asynchronous behavior involved at all. Now, what makes this code example asynchronous is simply the fact that the image is loading asynchronously in the background, but not the fact that we are listening for the load event to happen. So what matters is the asynchronous behavior of a task, like running a timer or loading an image. And there are more examples of asynchronous behavior in JavaScript, like the geolocation API that we used before, or AJAX calls. And AJAX calls are probably the most important use case of asynchronous JavaScript. And so let's see what AJAX is all about. So AJAX stands for Asynchronous JavaScript and XML, and basically it allows us to communicate with remote web servers in an asynchronous way. Now in practice, we make AJAX calls in our code in order to request some data from a web server dynamically, so without reloading the page, so that we can use that data in our application dynamically. For example, right in the next video, we're going to make AJAX calls to request data about countries. And we can then use that data about countries to build a small application that shows us information about the country that we're currently in. And the possibilities and use cases are endless. But more about that in the next slide. For now, let's quickly understand how AJAX works. So let's say that we have our JavaScript application running in the browser, which is also called the client, and we want the application to get some data from a web server. And let's say the data about countries that I was talking about earlier. So with AJAX, we can do an HTTP request to the server which has this data. And the server will then set back a response containing that data that we requested. And this back and forth between client and server all happens asynchronously in the background, just the way we learned before. And there can even be different types of requests, like GET requests to receive data or POST requests to send data to a server. But there is a whole lecture about this a bit later to really show you how it all works in detail. Now, when we're asking a server to send us some data, this server usually contains a web API. And this API is the one that has the data that we're asking for. So an API is something pretty important, and so let's now see what an API and web APIs actually are. So first of all, API stands for Application Programming Interface. Now, in general terms and on a very high level of abstraction, an API is basically a piece of software that can be used by another piece of software in order to basically allow applications to talk to each other and exchange information. And that's true not only for web development and JavaScript, but for programming in general. Now, in JavaScript and web development, there are countless types of APIs, like the DOM API or the geolocation API that we have been using. So these are called APIs because they are a self-contained piece of software that allow other pieces of software to interact with them. For example, our map-t application that we built in the previous section. Also, we can always implement a small and simple API in a class where we make some methods available as a public interface. Remember? So again, objects made from a class can be seen as self-contained, encapsulated pieces of software that other pieces of software can interact with. And so that fits the definition of API, right? But now, let's talk about the important type of API that we are actually interested in when we use AJAX. And that are APIs that I like to call online APIs. So an online API is essentially an application running on a web server which receives requests for data, then retrieves this data from some database and then sends it back to the client. So just as we saw in the last slide, right? Now, when building applications in practice, we simply call these online APIs API. And many people will also call these APIs web APIs, or again, just simply API. So the term online API is actually a term that I came up with myself, because the term web API is actually also used for other things. Now, of course, we can build our own online APIs, but that requires back-end development. So development with servers and databases and all that. And this is something really interesting that you can learn after this course. And I actually have a course on Node.js myself that you can check out if you're interested. But anyway, for now, we are interested in using third-party APIs. So APIs that other developers make available for us, most of the times for free. So let's now imagine that you're building a traveling application and you have a database with different destinations and tours that you're offering. So on your own server, you could build your own API that can receive requests from your front-end application in JavaScript and send back the results. So that would be your own API hosted on your own server. But that alone would probably not be enough to build a complete application. And so you could also use some third-party APIs. And there are really APIs for everything. So in our example travel application, you could use an API to get weather data in your destinations, data about the destination countries themselves, data about flights, about currency conversion, and you could even use APIs to send emails or text messages or embed Google Maps into your applications. So as you see, the possibilities are really endless with APIs. And we can even say that APIs is what made the modern web, as you know it, possible in the first place. So using APIs in JavaScript is super popular and everyone does it all the time. And so that's why I'm explaining you all these details. Okay, but now just to finish, let's quickly talk about API data formats. So AJAX stands for asynchronous JavaScript and XML. Remember? So the X there stands for XML. And XML is a data format which used to be widely used to transmit data on the web. However, these days, basically no API uses XML data anymore. The term AJAX is just an old name that got very popular back in the day, and so it's still used today, even though we don't use XML anymore. So instead, most APIs these days use the JSON data format. So JSON is the most popular data format today because it's basically just a JavaScript object but converted to a string. And so therefore, it's very easy to send across the web and also to use in JavaScript once the data arrives. All right. So now that we know what asynchronous JavaScript is, and also what AJAX and APIs are, let's finally use all this in practice and make our very first AJAX call in the next video. So now that we know about AJAX and APIs, let's actually make our first API call. So in this lecture, we're going to build a nice UI component such as this one here, which contains data about a certain country. And this data about the countries is actually going to come from a third-party online API. So just as we learned it in the last video. So here we have this first card for Portugal, and then another card for the USA. And of course, this would work for any country in the world. And this is actually really exciting stuff to me. So I think it feels really magical and next level to be able to do this. So to kind of magically get this kind of data from the internet and then work with it in any application that we're building. And so let's now start working on this. And as always, I already have my starter files up here in VS Code. And I also already started the live server. And so that's what I have here open. And so now let's get to work. Now in JavaScript, there are actually multiple ways of doing AJAX calls, but we're going to start with the most old school one. And that's called the XML HTTP request function. So we can do new XML HTTP request. So just this one here. So we call this function, and then all we need to do for now is to store the result in a new variable. So let's call this one request. And so that's the first step of using the XML HTTP request way of doing AJAX calls. Now, again, as I mentioned, this is the old school way of doing AJAX in JavaScript, but I'm still showing it to you for two reasons. So first, I want you to know that XML HTTP request exists because you might actually need it in the future. And second, I want to show you how AJAX calls used to be handled with events and callback functions. And so only after that, we should move on to a more modern way of handling asynchronous JavaScript, which is going to be a feature called promises. But anyway, next we need the URL to which we will make the AJAX call. So we can now say request, so that object that we created here, dot open. And then here, first, we need to pass in the type of request. And remember that the type of HTTP request to get data is simply called get. And second, we need a string containing the URL to which the AJAX call should actually be made. So let me now show you the API that I selected for this project and also how we can use it so that you can actually understand how you could do something similar yourself. So on GitHub, there is this huge repository, as you can see here, which is called public APIs. And so if you just Google for that, I'm sure that you will find it. And here is a list of a ton of public and free APIs that you can use. So we have all these different categories here. And so there's really an API for everything. So just as I said in the last video. And the one that we are going to use is called REST countries. So it's this one here. All right. So we see here that, well, this is a big table. So we see that the API we are going to use needs no authentication. I think it uses HTTPS, and I'm not sure about CORS. And this one here is important. So any API that you use here should always have CORS set to yes, or maybe to unknown. All right. And CORS stands for Cross-Origin Resource Sharing. And without CORS, we cannot access a third-party API from our own code. And so going back here, well, now it's gone. Here it is. So you see, it doesn't need authentication and it uses HTTPS. So this is a good one. And so let's click it, which will take us basically to the documentation page. And now here I'm simply looking for a so-called API endpoint. And so the endpoint is essentially just another name for the URL that we need. So here we have the first URL, and this one is basically for all countries. So if we wanted to get a list of all the countries from this API, we could make an AJAX call to this URL here. Okay? But that's not what we want. Instead, I want to search the API by country name. And so therefore, this here is the URL that I'm going to use. So let's copy it. And I hope that you followed these steps here. And if not, you can, of course, simply paste it here. All right. And I will start with Portugal. But you can, of course, use your own country. So with this, we basically open the request. And now next, we need to also send it. So you see, there are a lot of steps involved when using this way of doing an AJAX call. Okay, and so this will now send off the request to this URL here. Now, in order to get the result, we couldn't simply do maybe something like this. So set some variable simply to this result here. And the reason why we cannot do this is because the result is simply not there yet, right? So this AJAX call that we just send off here is being done in the background while the rest of the code keeps running. And so this is the asynchronous non-blocking behavior that we talked about in the last lecture. So let's get rid of this. And instead, what we need to do is to register a callback on the request object for the load event. So request, and then again our old friend add event listener. And here on the request, we will wait for the load event. So again, here we basically send off the request. And so that request then fetches the data in the background. And then once that is done, it will emit the load event. And so using this event listener, we are waiting for that event. And so as soon as the data arrives, this callback function here will be called. Now, let's then actually log the result to the console. So the this keyword inside of this function is the request, right? So we could also do request, but let's just use the this keyword. And then the response is in the property response text. And again, this property here is of course only going to be set once the data has actually arrived, right? So if we tried to set it out here, then that wouldn't work, of course. So we can still try that just to see request.response text. And so that would be exactly the same as this one. And well, already we have our first data here. So that's great. And as you see, this is the result of our very first AJAX call. So great job. This already worked. And you see that this kind of looks like a bunch of data about Portugal indeed. Now we just need to convert this here to an actual JavaScript object, because what we have here right now is JSON. So remember that JSON is basically just a big string of text. And so what we need to do here is to then convert that. We already did that before, actually. So that's JSON.parse this.response text. So let's then take a look at the data. And by the way, as you see here, of course, the result of request.response text out here is nothing, right? So let's get rid of it. And so indeed, here we have this object with all this data about Portugal. So we have the capital, which is Lisbon. We have the flag even. So basically a link to the image of the flag. And indeed, this is where we're going to get this flag here from. And then all kinds of other stuff, like the location, the population, region, and so on and so forth. Now you see that this is actually an array containing one object. And so let's quickly destructure that like this. So remember, that would be the same thing as doing this, right? But of course, destructuring is a lot more beautiful. And so now we got immediately the object here. Great. And now we can actually build that card component. And so let's copy the HTML here from this comment. So open the index.html file, get the HTML from there, and then we can create a template literal that we then have to fill up. Here I'm of course missing the name, and as always I'm calling it HTML. And so now all we have to do is to replace this data. So let's open it to see what we actually have. So here we are actually starting with the image. So we need a source, and of course that source can be any URL. It doesn't have to be a local image that we have on our computer. And so the one we will use is this one here. And so that is at data.flag. Next up, this is where the actual name of the country goes. So data dot, and where, yeah. So down here is the name. Then here, I also want the region. So that would be Europe in this case. And so this is the one. So that's data dot region. And then finally, we also want some information about the population, language, and currency. And all of that is present here in this data. So that's at data dot population. And so this here is basically 10 million. So we don't want to display this entire number. So let's just round it to 10.3 or 10.4 million. So the way we can do that is to convert this first to a number. So as always, I'm just using plus for that. Then divide it by 1,000,000. So yeah, that's 1,000,000. And then let's round this value finally. So this is a number, and so on a number we can call 2 fixed with 1 decimal place. Next up, language. So I'm doing this pretty fast because here we are basically just practicing what we already know, right? So again, this one is for languages, and so let's see. So languages is basically an array. Oh, now I clicked, and so now it's gone. So let me just put something else here for now, because this was causing the error. So let's see. In languages, we have multiple here, as you see. And so what we want is simply the first element of the languages and then the name. And the same is actually going to happen with the currencies. So we also have an array of the currencies, and then we want the name of the first one. So again, we want data dot languages, the first element, and from there we want to take the name, and the same with the currencies. Currencies. All right, and that should be it. And now all we have to do is to then actually insert this HTML into our page. So I actually already have it here selected, but just to make it complete, let me show it to you. So we have this countries element here, and so that's what I call the countries container. And so here we want country.insert adjacent HTML before end, and then the HTML that we just created. Now finally, we also need to set the style of this container to opacity 1. So let me show you that one also in the code. So I set the opacity of the countries container here to 0. And so now we set it to 1 so that we can then see a nice animation, which is going to be triggered by this transition. Okay. First, let's give us some space so we can then actually see it. And so, as I just said, we need to say countries container dot style dot opacity and set it to 1. And now as I save it, the data should appear, and it does. So that's amazing, right? And it looks just like here in our demo. So that's fantastic. I really love it when it works just like this. So getting data from some third-party API really feels like magic to me. Now let's actually reuse the same code here to create an element like this for multiple countries. And so what I'm going to do is to put all of this into a function. Let's call it getCountryData. And so this one will take a string as an input of a country. Okay, so the curly brace down here. And then here, instead of hard coding Portugal, we will use that country that we get as an input. All right, country. And now down here, we can then call this function get country data Portugal. So let's see. And yep, that worked just the same. And now let's try another one. So let's try the United States of America, just like I had it in my demo. And here we go. So now we have data about 2 countries. And by calling these functions here twice, we will basically have 2 AJAX calls happening at the same time. So in parallel, so to say. And if we reload this page here a couple of times, then they might appear in a different order. And the reason for that is basically that the data arrives at a slightly different time each time that we're loading the page. And so, in fact, this really shows the non-blocking behavior in action. So as we call get country data here with Portugal for the very first time, it sends off this request, and then JavaScript moves on in the code right away. And so it goes right here to this next line. And this, of course, fires off another AJAX call immediately, way before the data of Portugal has actually arrived. So again, we will have 2 AJAX calls happening at the same time. And so whatever one arrives first will then fire the load event first. And so if the first one is the AJAX call for the USA, well, then the first element that's going to be printed here will, of course, be the one from the USA. And only after that, the data for Portugal arrives. And then this callback function here is called with the data of Portugal. And of course, the same would be true no matter how other requests we would fire off here. Let's say Germany here. And so now we actually got the data in the same order, but so now it's actually completely different. And so this confirms what I just explained before. Now, if we actually wanted these requests to be made in a specific, like predefined order, then we would basically have to chain the requests, which means to make the second request only after the first request has finished. And that's actually what we're going to do in the next lecture, so that I can show you something that we developers call callback hell. If you want to go really deep and really understand how requests and responses work on the web, then this video is for you. So this is basically a high-level overview of how the web actually works behind the scenes in regard to requests and responses. Now, this knowledge is not required though for moving on in the course, and that's why I marked this video as optional. So you can safely skip it if you want to move on more quickly, but if you're interested, then just keep watching. So this is the diagram that we already saw when we first talked about AJAX calls. So just to recap, whenever we try to access a web server, the browser, which is the client, sends a request to the server, and the server will then send back a response. And that response contains the data or the web page that we requested. And that's right, this process works the exact same way, no matter if we're accessing an entire web page or just some data from a web API. And this whole process actually has a name, and it's called the request response model, or also the client-server architecture. But anyway, let's now dive a bit deeper into this. So let's use the example of the URL that we actually accessed in the last video to get our country data. Now, every URL gets an HTTP or HTTPS, which is for the protocol that will be used on this connection. And we're going to talk about this a bit later in the video. Then we have the domain name, which is restcountries.eu in this case, and also after a slash, we have the so-called resource that we want to access. And in this case, that's /rest/v2, and so on. Now, this domain name restcountries.eu is actually not the real address of the server that we're trying to access. It's really just a nice name that is easy for us to memorize. But what this means is that we need a way of kind of converting the domain name to the real address of the server. And that happens through a so-called DNS. So DNS stands for Domain Name Server, and domain name servers are a special kind of server. So they are basically like the phone books of the internet. So the first step that happens when we access any web server is that the browser makes a request to a DNS, and this special server will then simply match the web address of the URL to the server's real IP address. All right? And actually, this all happens through your internet service provider, but the complete details don't really matter here. What you need to retain from this first part is that the domain is not the real address and that a DNS will convert the domain to the real IP address. And then, after the real IP address has been sent back to the browser, we can finally call it. So this is how the real address looks like. So it still has the protocol, but then comes the IP address and also the port that we access on the server. And this port number is really just to identify a specific service that's running on a server. So you can think of it like a sub-address. Okay. This port number has nothing to do with the /rest/v2 resource that we want to access. So that resource will actually be sent over in the HTTP request, as we will see in a moment. Okay, and that actually wraps up the first step. So once we have the real IP address, a TCP socket connection is established between the browser and the server. And so they are now finally connected. And this connection is typically kept alive for the entire time that it takes to transfer all files of the website or all data. Now, what are TCP and IP? Well, TCP is the Transmission Control Protocol, and IP is the Internet Protocol. And together, they are communication protocols that define exactly how data travels across the web. They are basically the Internet's fundamental control system, because, again, they are the ones who set the rules about how data moves on the Internet. And don't worry if that sounds confusing, we are actually going to learn a bit more about TCP/IP a bit later in this video. But anyway, now it's time to finally make our request. And the request that we make is an HTTP request, where HTTP stands for Hypertext Transfer Protocol. So after TCP/IP, HTTP is another communication protocol. And by the way, a communication protocol is simply a system of rules that allows two or more parties to communicate. Now, in the case of HTTP, it's just a protocol that allows clients and web servers to communicate. And that works by sending request and response messages from client to server and back. Now, a request message will look something like this. The beginning of the message is the most important part, called the start line, and this one contains the HTTP method that is used in the request, then the request target, and the HTTP version. So about the HTTP methods, there are many available, but the most important ones are GET for simply requesting data, POST for sending data, and PUT and PATCH to basically modify data. So you see that an HTTP request to a server is not only for getting data, but we can also send data. All right. Now about the request target, this is where the server is told that we want to access the rest/v2/alpha resource in this case. Remember that? So we had this in the URL before, and now it is simply sent as the target in the HTTP request. And so then the server can figure out what to do with it. Now, if this target was empty, so if it was just a slash, basically, then we would be accessing the website's root, which is just restcountries.eu in this example. Then the next part of the request are the request headers, which is just some information that we sent about the request itself. There are tons of standard different headers, like what browser is used to make the request, at what time, the user's language, and many, many more. Now finally, in the case we're sending data to the server, there will also be a request body. And that body will contain the data that we're sending, for example, coming from an HTML form. So that is the HTTP request, and I hope that it makes sense to you. Now, of course, it's not us developers who manually write these HTTP requests, but it's still helpful and valuable that you understand what an HTTP request and also a response look like. Also, I want to mention that there's also HTTPS, as you probably know. And the main difference between HTTP and HTTPS is that HTTPS is encrypted using TLS or SSL, which are yet some more protocols, but I'm not going to bore you with these. But besides that, the logic behind HTTP requests and responses still applies to HTTPS. All right, so our request is formed, and now it hits the server, which will then be working on it until it has our data or web page ready to send back. And once it's ready, it will send it back using, as you can guess, an HTTP response. And the HTTP response message actually looks quite similar to the request. So also with a start line, headers, and a body. Now in this case, the start line has, besides the version, also a status code and a message. And these are used to let the client know whether the request has been successful or failed. For example, 200 means OK. And the status code that everyone knows is 404, which means page not found. So that is where this 404 code that everyone already knew comes from. Okay? Then the response headers are information about the response itself. So just like before, and there are a ton available, and we can also make up our own, actually. And finally, the last part of the response is, again, the body, which is present in most responses. And this body usually contains the JSON data coming back from an API or the HTML of the web page that we requested, or something like that. So we talked in great detail about the most important parts here, which are the HTTP request and the response. But in our imaginary example, we only just did one request to restcountries.eu and got one response back, right? And that's how it's going to work when all we do is to access an API. However, if it's a web page that we're accessing, then there will be many more requests and responses. And that's because when we do the first request, all we get back is just the initial HTML file. That HTML file will then get scanned by the browser for all the assets that it needs in order to build the entire web page, like JavaScript, CSS files, image files, or other assets. And then for each different file, there will be a new HTTP request made to the server. So basically, this entire back and forth between client and server happens for every single file that is included in the web page. However, there can be multiple requests and responses happening at the same time. But the amount is still limited because otherwise the connection would start to slow down. But anyway, when all the files have finally arrived, then the web page can be rendered in the browser according to the HTML, CSS, and JavaScript specifications that you already know. Now, as a final piece of the puzzle, let's talk again about TCP/IP and figure out how this request and response data is actually sent across the web. Okay, so we said before that TCP and IP are the communication protocols that define how data travels across the web. Now, I'm not going to go into a lot of detail here, but here is what you need to know. So first, the job of TCP is to break the requests and responses down into thousands of small chunks called packets before they are sent. Once these small packets arrive at their final destination, TCP will reassemble all the packets into the original request or response. And this is necessary so that each packet can take a different route through the internet. Because this way, the message arrives at the destination as quick as possible, which would not be possible if we sent the entire data simply as a big chunk. So that would be like trying to go through dense traffic with like the biggest bus that you can imagine. So probably not a good idea. Now, as a second part, the job of the IP protocol is to actually send and route these packets through the internet. So it ensures that they arrive at the destination they should go using IP addresses on each packet. Okay, and that's it. That's a broad overview of what really happens behind the scenes of the web. And I hope that you found this information useful and also interesting and not all too confusing. But anyway, now let's go back to our JavaScript and AJAX calls. So in the last lecture, we did a simple AJAX call to fetch data from a country's API. So we created a function for that, and as we called the function multiple times, multiple AJAX calls were made at the same time. So they were basically running in parallel, and we could not control which one finished first. Remember that? However, in this lecture, let's create a sequence of AJAX calls so that the second one runs only after the first one has finished. And here's what we're going to do. So in the country's data here, there is some property of the bordering countries. So you see, this one here has the code ESP, which stands for Spain. And so that's because Spain is a bordering country of Portugal. And so what we will do now is after the first AJAX call is completed, we will get this border, and then based on this code, we will also render the neighboring country right here besides the original country. And so in this case, the second AJAX call really depends on the first one, because the data about neighboring countries is of course a result of the first call. So without the first call, we wouldn't even know which data to fetch in the second call. And so what we need to implement is a sequence of AJAX call. So here I already copied the function from the last lecture, which is still up here. And so let's call this one here now get country and neighbor. Okay, so again we get the country as an input, and then here we do the first AJAX call, and then once the load event is fired, when the data arrives, we then handle that data. And so everything that we have here is still the same. Now, we will do this part here another time. So basically, once the neighboring country arrives, we also will want to render this one. And so let's export this functionality into its own function so that we don't have to copy it later. And this also makes this function a little bit cleaner. So render country is going to be a function which simply takes in some data. And so like this, we don't have to change the variable names in here. Okay. And so now here, let's then actually call that function. So render country with data. And now we get this error here because of course this function no longer exists. So get country and neighbor. So as I save this now, this should look the same as before. And so indeed it does. Okay, But now here, let's actually get the neighbor country. So let's write that. Get neighbor country. And here, actually, let's also do some comments now. So render country 1, let's say. And here I will say Ajax call country 1. So the neighbor country will then be country 2. So the neighbor is going to be data.borders, I believe. So let's just check that here again. And so this is actually an array. And so we will simply render the first element. So in the case of Portugal, there is just one border, but in other countries like Germany, there's like 10 borders or something. So let's just destructure here, basically just take the first element. But of course, there are also countries which have no neighbors at all. So islands, basically. And so for these cases, let's simply make sure that we don't run into any mistakes. And so in that case, we simply return immediately. But of course, if the neighbor does exist, then now we can do the second Ajax call. And so let's copy all of this. And so here, Ajax call 2. And now here, of course, we don't want to use the country, but we want to use the neighbor. But there is one particularity about that, because here the border, so this one here, this country, actually doesn't come with the name of the country, but with this code. Okay? But using our API, we can actually also search by the code. So right here we have that. So right now we are using the name, but as I said, we can also search for the code. And so all we have to change is basically here from name to alpha. So that's alpha here, and then here, the neighbor. All right. Okay. And so now, just like before, we have to then listen for the load event on this new request. And let's call this request 2, because of course we can't do that on the same request that we did here in the beginning. So request 2, add event listener, load, and then our callback function. And so you're starting to see now that the second Ajax call, in the way we are setting it up here, is really dependent on the first one. So that's because basically we are firing off the second Ajax call here in the callback function of the first one, right? So basically inside of this callback function, we are now adding a new event listener for the new request. And so here we now have one callback inside of the other one. All right. And so we will talk about that once we have this code working. But for now, let's actually take a look at the result here. And so that's going to be request, or actually just a this keyword. So this dot response text. So let's see. And indeed, now we got data about Spain. And no matter how many times we reload the page, it will now always appear after Portugal. All right? Because there's no way that this Ajax call here can be made before the one on Portugal. Okay? And so now, well, let's just do the same as we did here. So we don't need this. Let's say data2 should be JSON.parse, and then this. And of course, we need to also destructure it then, logging it to the console. But now we get some error here. So let's just take a look at the result itself without any destructuring. Oh, and so now it works. And the reason for that is that the response of this API is actually no longer an array when we search for the code. So here we have this alpha, remember, and so this time we are searching for country codes and not for country names. And so the country codes are unique, and so therefore they can always just be one result. And so that's the reason why no array is returned. And probably it says here so in the documentation. Well, it doesn't say so, but if we would have just simply inspected the response here, then we would have understood that as well. But anyway, now it worked, and so let's now render this country here as well. So data2, and now let's wait, and there it is. Great. Now actually I created a special class here for the neighboring country so that it appears a little bit smaller. And so when it is the neighbor, we want to attach some class here to the country. And so let's pass that class in. So let's say class name, and by default we set it to nothing. So here we will just add it to the string like this. And now when it is a neighbor, we can just pass in neighbor like this. Give it a save, and yeah, so that looks a bit nicer. We get the information that this is a neighbor country. And so now let's try this, for example, for the USA as well. But now I just want to do one at a time. So here we should probably get Mexico or Canada. And indeed, here it is. Here is Canada, the neighboring country of the US. And so one more time, this second AJAX call would not have been possible without the first one. Because otherwise, how would we know that the second country here needed to be Canada? Okay, so again, we have one AJAX call here that depends on another one. And so what we have here is one callback function inside of another one. So you see, here we attach the first callback function, and then inside of that, we have yet another one. So in other words, here we have nested callbacks. But now imagine that we wanted to do more requests in sequence, like the neighbor of the neighbor of the neighbor, and like 10 times over. So in that case, we would end up with callbacks inside of callbacks, like 10 times. And actually, for that kind of structure and for that kind of behavior, we have a special name. And that special name is callback hell. So basically, callback hell is when we have a lot of nested callbacks in order to execute asynchronous tasks in sequence. And in fact, this happens for all asynchronous tasks which are handled by callbacks, and not just AJAX calls. So, for example, let's say we have a setTimeout function, and then here we want to log something to the console like 1 second passed, but then also we want to start another timeout. Let's just set 1000 here. So let's copy this one here. And so, as I just said, let's say that here we wanted to start a new timer after the first timer has finished. So here we can say 2 seconds passed, and we can even add another one. So never mind about what just happened in the console. And here, why not add yet another one? All right. And so now they should appear like 1, 2, 3, 4. And so here too, of course, we have callback hell. And in fact, callback hell is pretty easy to identify by this triangular shape that is formed here. You see that? And also the same is starting to appear here. Right? So if we had more callbacks in here, then we would start to see a lot more indentation here. And then this triangular shape would also appear there. Now, the problem with callback hell is that it makes our code look very messy. But even more important, it makes our code hard to maintain and very difficult to understand and to reason about. And code that is hard to understand and difficult to reason about will have more bugs and is just worse code. So this is a great rule that you should always remember and keep in mind. So again, the rule is that code that's hard to understand is basically bad code because it will have more bugs. Because the harder it is to understand code and to reason about the code, the more difficult it will be to add new features and to add more functionality to the application. But anyway, given all these problems with callback hell, we of course need a way to solve callback hell. And fortunately for us, since ES6, there is actually a way of escaping callback hell by using something called promises. And so let's now take the next step in our journey of asynchronous JavaScript, which is to learn all about promises. In the last video, we got a glimpse into callback hell, and it was not pretty. So in this lecture, let's learn about a modern JavaScript feature called promises, so that we can escape callback hell. However, before we learn about promises, we should actually see one. And so let's now replace the old XML HTTP request function with the modern way of making AJAX calls. And that is by using the fetch API. So let me go up here to our first function, and I will just copy all of this just to see how it used to work and how we can do it now. Okay, so this is how we used to do it, and now all we need to do is to call fetch, and then with our URL, so let's just grab that part and then specify Portugal, and that's actually it. All we have to do now is to store the result into a variable, and let's still call it request here. Now there are actually some more options that we can specify here in the fetch function if we'd like, but to make a simple GET request like this one, all we really need is to pass in the URL, and that's it. So for more complex AJAX calls, the fetch function can take in like an object of options as well, but again, for now we don't need that. But anyway, let's now give it a save, and well, we should also log the request to the console to see what happens. And so you see that the fetch function immediately returned a promise here. So as soon as we started the request, we stored the result of that into the request variable, and then as we logged it, we immediately got the promise here. So let's do that again. And again, right away, we got something called promise. And here it says pending. So if we open that up, then here it says fulfilled. And we also have like a value here, but I'm not going to go into full detail just yet. So what matters here is that now we actually have a promise. And so this promise is right now stored in this request variable. But now, what exactly is a promise and what can we do with it? Well, let's find out. So the formal definition of a promise is that it's an object that is used basically as a placeholder for the future result of an asynchronous operation. And if that sounds weird to you, we can also say that a promise is like a container for an asynchronously delivered value. Or even less formal, let's say that a promise is a container for a future value. So there you go. That's the most distilled down definition of what a promise is. So a container or a placeholder for a future value. And a perfect example of a future value is the response coming from an AJAX call. So when we start the AJAX call, there is no value yet, but we know that there will be some value in the future. And so we can use a promise to handle this future value. And don't worry, this will really make sense once we go back to code. But to understand this concept even better, I like to use the analogy of a lottery ticket. So a promise is just like a lottery ticket. So when I buy a lottery ticket, essentially I buy the promise that I will receive some amount of money in the future if I guess the correct outcome, right? So I buy the ticket now with the prospect of winning money in the future, and the lottery draw, which determines if I get the money or not, happens asynchronously. So of course, I don't have to drop everything and keep waiting until the lottery draw happens, right? Now, in case I did get the correct outcome, then I will receive my money, because I have my lottery ticket, which is the promise that I bought. Now, what's the big advantage of using promises? Well, there are two of them actually. First, by using promises, we no longer need to rely on events and callback functions to handle asynchronous results. Events and callback functions can sometimes cause unpredictable results, and so this is a big win already. But even better, with promises, we can chain promises for a sequence of asynchronous operations instead of nesting like we did in the last video. And with this, we can finally escape callback hell, which was our initial goal all along. And by the way, promises are an ES6 feature, so they became available in JavaScript in 2015. And so by now, they are widely used by everyone. Now, since promises work with asynchronous operations, they are time sensitive, so they change over time, and so promises can be in different states. And this is what we call the life cycle of a promise. So in the very beginning, we say that the promise is pending. And so this is before any value resulting from the asynchronous task is available. Now, during this time, the asynchronous task is still doing its work in the background. Then, when the task finally finishes, we say that the promise is settled. And there are two different types of settled promises, and that's fulfilled promises and rejected promises. So, a fulfilled promise is a promise that has successfully resulted in a value just as we expected. For example, when we use a promise to fetch data from an API, a fulfilled promise successfully got that data, and it's now available to being used. On the other hand, a rejected promise means that there has been an error during the asynchronous task. In the example of fetching data from an API, an error would be, for example, when the user is offline and can't connect to the API server. Now, going back to the analogy of our lottery ticket, the lottery draw is basically the asynchronous task which determines the result. Then, once the result is available, the ticket would be settled. Then, if we guessed the correct outcome, the lottery ticket would be fulfilled and we get our money. However, if we guessed wrong, then the ticket basically gets rejected and all we did was waste our money. Now, these different states are very important to understand because when we use promises in our code, we will be able to handle these different states in order to do something as a result of either a successful promise or a rejected one. Another important thing about promises is that a promise is only settled once, and so from there, the state will remain unchanged forever. So the promise was either fulfilled or rejected, but it's impossible to change that state. Now, these different states that I showed you here are relevant and useful when we use a promise to get a result, which is called to consume a promise. So we consume a promise when we already have a promise. For example, the promise that was returned from the fetch function right at the beginning of this video. Remember? But in order for a promise to exist in the first place, it must first be built, so it must be created. In the case of the fetch API, it's the fetch function that builds the promise and returns it for us to consume. So in this case, we don't have to build the promise ourselves in order to consume it. Now, most of the time, we will actually just consume promises, which is also the easier and more useful part. And so that's what we will do in the next couple of videos. But sometimes we also need to build a promise and not just consume it. And of course, we will also learn how to do that a bit later. All right. And so now let's actually start using promises in the next video. In this lecture, we will learn how to consume a promise. And in this case, we will consume the promise that was returned by the fetch function. So let's now implement the getCountryData function from the very first lecture, but of course this one using a promise. So getCountryData, and so again, here we pass in a country, and then here we will want this fetch function, and here again with the country then. So making this a template, literal again, and then country. And as we already know, calling the fetch function like this will then immediately return a promise, so as soon as we start the request. And in the beginning, this promise is of course still pending, because the asynchronous task of getting the data is still running in the background. So just as we learned in the last lecture. Now, of course, at a certain point, the promise will then be settled, and either in a fulfilled or in a rejected state. But for now, let's assume success. So assume that the promise will be fulfilled and that we have a value available to work with. And so to handle this fulfilled state, we can use the then method that is available on all promises. So just like this. So again, this here will return a promise, and on all promises we can call the then method. Now into the then method, we need to pass a callback function that we want to be executed as soon as the promise is actually fulfilled. So as soon as the result is available. So a function, and then this function will actually receive one argument once it's called by JavaScript. And that argument is the resulting value of the fulfilled promise. So let me call it response here, because this is the response of an AJAX call in this case. All right, and that's it. So this is how we actually handle a fulfilled promise. But now let's actually do something with the response here. And as always, I will start by logging it to the console. But of course, we also need to call this function here. All right. And so here we now get the response indeed. And even the type of this object is actually called response. Let's just get rid of this here for a second. So we have a cleaner output here. All right. And so here indeed we have a couple of things about the response itself. For example, here the status code or the headers. And so if you watch the lecture about how the web actually works behind the scenes, then this kind of data here will be familiar to you. But anyway, what we're actually interested in is the data itself. And so that data is in the response body here. So let's click here just to see. And as we see, the body is basically this readable stream. All right. And so actually we cannot yet really look at the data here. So in order to be able to actually read this data from the body, we need to call the JSON method on the response. Okay. So JSON is a method that is available on all responses of the fetch method. So what I mean is this. So response.json. So again, the JSON method here is a method that is available on all the response objects that is coming from the fetch function. So all of the resolved values. And indeed, this response here is in fact a resolved value. And so therefore, it does have the JSON method attached to it. Now the problem here is that this JSON function itself is actually also an asynchronous function. And so what that means is that it will also return a new promise. And that's all a bit confusing. and I really don't know why it was implemented like this, but this is just how it works. So anyway, what we need to do now here is to actually return this promise from here, okay? Because remember, this here will be a new promise, okay? And so now we need to handle that promise as well, all right? And so the way we do that is to then call another then right here. So we need another callback function. This time let's call it data. And for now, let's log it here to the console. And let's give it a save just to see if it worked. And yeah, here it is. So here we are back to having the same data that we already had before, but this time using a promise, or actually two promises. So let's recap what happened here. And the first part here, I think, is pretty straightforward, which is this fetch function here returning a promise, and then we handle that promise using the then method, right? But then to actually read the data from the response, we need to call the JSON method on that response object. Now this itself will also return a promise, and so if we then return that promise from this method, then basically all of this becomes a new promise itself. And so since this is a promise, we can then again call the then method on that. And so then again, we have a callback, and this time we get access to the data because the resolved value of this promise here is going to be the data itself. So basically the data that we're looking for, which is then this one here, right? And so now all we have to do is render country of data 0. Okay? And so here it is. So we just did the same thing as before, but using promises. And if we didn't have all of these console.logs here, we could actually simplify this a lot. So let me just copy it so that we get to keep this version as well. But then we can create a highly simplified version as well. So getting rid of this console.log and this one here. And then we can transform these here to arrow functions. And so this is going to work because this one will now implicitly return this result here. So this promise. And so then on that promise, we can call another then method. All I'm doing here is to simplify the code that we already had before. And you see that indeed it still works. So what do you think looks cleaner and nicer? Is it this code here using fetch and promises, or is it this function that we wrote right in the beginning with all of this weird stuff that we have going on here, and with this event and listening for the event, and even worse here with all these nested callbacks? So I hope that you agree that this here is actually a lot nicer. But beside being nicer, the code is also easier to read and to reason about. And as I mentioned before, that in itself is very important. So it's very easy to understand that this fetches something, and then we get a response, which will be transformed to JSON, and then we take that data and render the country to the DOM. Okay, so this almost reads like English sentences, and that's very helpful to understand the code now and also in the future. Now, just to finish, you might be thinking, well, we're still using callbacks here, right? And that is actually true. So promises do not get rid of callbacks, but they do in fact get rid of callback hell. So even if this doesn't look like a big change for now, it will look like a change after we add the functionality of loading the neighbor country like we did in the previous lecture. And so actually, let's go do that now in the next lecture. Let's now learn how to chain promises in order to also render the neighboring country of the initial country that we give to the function. And actually, we already have a small chain of promises because of this JSON function. And so here, these two dens called in sequence are basically already a small chain. But anyway, in this lecture, we will now take chaining to a new level and actually chain together two sequential AJAX calls. So just like before, we first get data about the country, and so that's the part that we already have here. But then we also want to get the data about the neighboring country. And so again, the second AJAX call depends on the data from the first call, and so they need to be done in sequence. So let's simply modify what we already have here. And so the second AJAX call basically needs to happen here in this den handler. So as soon as we get the data, then we need to get the neighbor country and do the AJAX call for that one as well. So let's get the neighbor, and we already know that it is at data 0 at borders, and then also the first one. And just like before, let's say if there is no neighbor, then return immediately. And actually this is not going to work, but never mind about this for now. So we will talk about error handling actually in the next video. Now here there is some kind of problem. We're missing the closing parenthesis here. All right. But now there is no error. And so let's do the second AJAX call. And let me just get the URL from up here. So that's this one. Okay. And so we use again fetch and then the URL. So let's call it country 2 and here country 1. All right. Now for now, this is not going to do anything because what we need to do now is to actually return this new promise. Because then when we do that, we will be able to chain a new den method on the result of this den method. All right. So that's a bit similar to what we did here with the JSON method, which remember also returned a promise. And so we return all of that promise here, and then we can chain a new den method onto that as well. Now in the last lecture, I actually oversimplified how things really work. So actually, the den method always returns a promise, no matter if we actually return anything or not. But if we do return a value, then that value will become the fulfillment value of the returned promise. So let me actually show that to you. So instead of returning this for now, let me just return 23. And so then when I chain a new den method here, let's say data, and then let's alert that data. Let's see. And then indeed we get 23. And so again, that happens because whatever we return from this promise here will become the fulfilled value of the promise. Okay? So again, this here returns a promise, and so we can handle it using the den method. And the fulfilled value, so the success value basically of the promise, will be the value that we return from this den method, right? And so that is this 23 here. And so therefore, in the next den method, then the data here will be 23. And of course, this here must be 23, otherwise we cannot see that in effect. But yeah, so it is 23 because this value is 23. So again, this data that we receive here as an input to this function is the fulfilled value of the promise that we're handling. And so again, that's this value 23 that we are returning from this den method here. Okay, but anyway, of course, the same is true for promises. And so by doing this, so by returning this promise here, then the fulfilled value of the next den method will be the fulfilled value of this previous promise. so of this one. Okay, so I know that sounds confusing, but what you need to understand is that basically this then method here returns a new promise, and here we can then one more time handle the success value of that promise. So one more time, I'm calling this one now a response, because here we are dealing with the fulfilled value of a fetch promise. And so that is a response. And so therefore I like to call it like that. And so here, one more time, we need to call the JSON method. And that is pretty annoying, but that's just how we have to do it. And so here again, the fulfilled value of the promise will become that body. So the data that is stored in the body. And then we can again handle that. So data like this, and then render country with data. And then here again, we pass in that CSS class for the neighbor. Okay, and that should already be it. And indeed, here we go. And if we try something else, let's say Germany, let's see what country we get. And it's Austria. Okay, but anyway, let's just put it back to this one here. And yeah, that's actually it already. So as you can see, promises really allow us to handle these complex asynchronous operations with as many steps as we want. So right now we have 4 steps here even, but of course we could extend this as much as we want. So even if we wanted the neighbor of the neighbor of the neighbor, like 10 countries, we could easily do this by chaining all these promises one after another, and all without the callback hell. So here, instead of the callback hell, we have what we call a flat chain of promises. And this one is, again, very easy to understand and to read. So as a conclusion to this video and the previous one, promises really are an incredibly powerful and elegant solution to handle asynchronous code. Now, just to finish, I want to show you a pretty common mistake that many beginners make, which is to basically chain this then method directly onto a new nested promise. So, as we know, this one immediately returns a promise, and so many beginners basically do this instead. Let me show it to you here. So instead of returning the new promise, they then chain the then method right here. So right inside of this then method. Now this actually does still work, but then we are in fact back to callback hell. Because now indeed we have one callback function here defined inside of another one. So inside of this enclosing callback function. Okay? And so of course, that's exactly what we're trying to avoid. And so don't do this. So always return the promise and then handle it outside by simply continuing the chain like this. All right, but I hope that this was already pretty obvious anyway from all the explanations that I gave you throughout this lecture and the previous one. But anyway, let's now move on and actually handle errors, because that is also a pretty common scenario when we work with promises, and especially with AJAX calls. So until now, we have always assumed that everything went well with our AJAX calls, so we never handled any errors. However, an important part of web development is to actually handle errors, because it's very common that errors happen in web applications. And so in this lecture, let's talk about how to handle errors in promises. And to start, remember that a promise in which an error happened is a rejected promise. And so in this video, we're going to learn how to handle promise rejections. Now, actually, the only way in which the fetch promise rejects is when the user loses his internet connection. And so for now, that's going to be the only error that we will handle here. Now, to simulate losing the internet connection, we can go here to network, and then we can basically change the speed here to offline. However, when we then reload the page, then basically everything will disappear. And so that's not really what we want. We want to simulate that the page was first still loaded, but then as the user does the request without internet, then we want to see the error happening. And so let's set it back to online. And so now what we want to do is to basically only call this function here whenever the user clicks on a button. And so that will then make it easier for us to simulate losing the internet connection. So here in the HTML, we already have a button. So let's comment this one out. And then in the script, I believe, yeah. So I already have it here selected as this btn. And so all we will do now is btn.addEventListener, click, and then here function, and just like this. All right. So just to see what happens here. So indeed, that works just fine. But now watch what happens when we set ourselves offline. Let's go back to the console. And so now when we do the request, then we get these errors here. So first, this one here. But the one that's most important is that we now have an on-caught promise. And so, because we have failed to fetch. And so at this point, for the first time, the promise that's returned from the fetch function was actually rejected. And so let's now handle that rejection. Now there are two ways of handling rejections. And the first one is to pass a second callback function into the then method. So the first callback function here is always going to be called for the fulfilled promise. So for a successful one. But we can also pass in a second callback, which will be called when the promise was rejected. So let's do that. And this callback function will be called with an argument, which is basically the error itself. And so let's simply alert the error. All right. So let's try that. Oh, and now we are back to having no internet. So we first need to do everything normally. So load the page. Now we lose the connection. And now we do the request. And so now actually we handled the error by displaying this alert window. And the error that we saw previously down here is now gone. So now, in fact, we no longer have this uncaught error down here because we did actually catch the error right here. So handling the error is also called catching the error. And so again, that's the reason why this error that we had here before disappeared. So it said uncaught error, but again, now we are actually catching it here. And so with this, we are now handling the error that might occur in this promise here. Okay. Now in this case, there are then no more errors because basically the chain stops here when this error happens and when it's handled right here. But now what if there was actually no error in this fetch promise here? So basically, what if this fetch promise was actually fulfilled, but then the second one here was rejected? Well, then we would also have to catch an error here. So we would have to come here, get this function and paste it here, and also handle the error right here. However, that is a little bit annoying, and so in fact, there is a better way of basically handling all these errors globally just in one central place. So instead of all of these callback functions here, let's just delete them. Okay, so this is a lot nicer just having one callback in the den. And then instead, we can handle all the errors no matter where they appear in the chain right at the end of the chain by adding a catch method. And then here we can actually use the same callback function because the callback function here will also be called with the error object that occurred. And so then we can handle it in some way. All right. So again, this catch method here at the end of the chain will basically catch any errors that occur in any place in this whole promise chain, and no matter where that is. So errors basically propagate down the chain until they are caught. And only if they're not caught anywhere, then we get that uncaught error that we saw right in the beginning. All right, so let's now try this again, and we will have to put back the internet, reload the page, get back offline, and indeed, we get the same error now here. So the same alert window that we had before. Now instead of having that annoying alert window, let's just log the error to the console and create some string here. So error, and then let's just add some emojis so that we know exactly which errors were printed by ourselves. Well, let's add a couple of them here. And in fact, we can actually also style this one with console.error. Remember? I think I showed you this one at some point in the beginning of the course. But anyway, usually simply logging the error to the console is not enough in a real application with a real user interface. And so instead of just logging something to the console, let's also display an error message for the user to see. And so that's then a more real use case of this catch block. All right, so I'm adding a new block here. So we still want to, of course, log the error to the console. But besides that, let's actually now create a function that will also render some kind of error. Okay, so let's do that outside here. And I'm calling it render error. So this is a function, and it can take in a message. Just call it like this. And just like the country elements, we want to attach this to country's container, and then insert adjacent. And this time not HTML, but insert adjacent text. So this is a new one, but basically it does the same thing as insert adjacent HTML, but simply with text. So it doesn't create any new HTML elements. Okay, and then besides that, remember, we always have to set the opacity back to 1. So just as we did before in the render countries function, because otherwise this container is not even going to be visible. And actually, let's put this function right at the very top of the file together with the render country function. So just like this. Okay, so again, in both cases, in order to actually see the container, we set the opacity to 1. Okay, and so now here, let's use that. Render, so not country, of course, error. Let's say something went wrong. Then here we can use our emoji again. Why not? And then here, let's again print the error. And actually, this error that is generated here is a real JavaScript object. So we can create errors in JavaScript with a constructor, for example, just like a map or a set. And any error in JavaScript that was created like this contains the message property. So we can use that here to basically only print the message of that error and not the whole object itself. And we will actually learn more about the built-in error object of JavaScript in the next video. Now to try this, we need to again get ourselves online. Then offline, check the console, and indeed, we get our custom error down here, visible by the emojis, and then our own message here for the user. Now it's not super pretty, but that's not the point here. And as you see, indeed, this here is simply the error.message. while down here we have the entire error. So that includes the type error, and even it includes this so-called stack trace. So it shows us exactly where the error comes from. All right, and so that's how we handle errors happening in promises in any then handler. So basically handling any promise rejection, no matter where it happens in the chain. Now, just to finish, there is one more quick method that I want to show you, and that is also available on all promises. So besides then and catch, there's also the finally method. So let's add a finally here. Finally, and then the callback function that we define here will always be called whatever happens with the promise. So no matter if the promise is fulfilled or rejected, this callback function that we define here is going to be called always. So that's the difference between the other two. So the then method is only called when the promise is fulfilled, while this one is only called while the promise is rejected. Now, the finally method is not always useful, but sometimes it actually is. So we use this method for something that always needs to happen, no matter the result of the promise. And one good example of that is to hide a loading spinner, like these rotating circles that you see everywhere in web applications when you load some data. So these applications show a spinner when an asynchronous operation starts, and then hide it once the operation completes. And that happens no matter if the operation was successfully or not. And so for that, the finally method is perfect. And in our case, what we always need to do is to fade in the container. So basically, this part here always happens no matter what, right? So no matter if we render the country in the case of success, or if we render the error in case of an error, no matter what, we always need to do this. And so let's take this out of here. So I'm copying it here and deactivating this in both cases. And then let's put it here into the finally handler. Okay, and now we no longer need the offline. So let's just reload, put it here, and yeah, that works beautifully. Just notice that this actually works because catch itself also returns a promise. So that's the only way why this here can work. So of course, this only works on promises. And so, yeah, again, this can only work if catch itself also returns a promise. All right. Now let's try to simulate another error so that I can show you what we need to do next. So let's say that we're trying to search for a country that simply doesn't exist. And so our API is not going to find any result for that. Let's say just this. So let's see. And well, we get this weird error that we cannot read property flag of undefined in line 152. No, so basically it's coming from this place. But of course, then in our stack trace, we can see where exactly it's coming from. So it's coming from get country data. Well, in this case, it's not that helpful, but sometimes inspecting this stack trace can be helpful indeed. So anyway, this error here is weird, and it doesn't really reflect the true error, which is simply that our API cannot find any country with this name. So the true error is of course not that we cannot read flag of undefined, but in fact, it is that our API cannot find any country. And so that's reflected here with the status code of 404. However, as I said in the beginning, the fetch promise only rejects when there is no internet connection. But with a 404 error like this, which is not a real error, but well, it kind of is. But anyway, with this 404, the fetch promise will still get fulfilled. So there is no rejection, and so our catch handler cannot pick up on this error. It does pick up on this other error, so this one here, but that's not the one that we actually want to handle. In this case, we really want to tell the user that no country was found with this name. And so that is what we will do in the next lecture, so that this one doesn't become all too long. So in this lecture, we're going to fix the request 404 error that we saw happening in the last lecture. And so as we saw in the last video, the problem here is that during the fetch, there was a 404 error, which is because our API couldn't find any country with this name. But still, even though there was obviously a big problem with this request, the fetch function still did not reject in this case. And by the way, many people, and that includes myself, think that in this case, the promise should actually be rejected right away. But again, it just doesn't, and so we will have to do it manually. So to see what happens here, let's go back to this first then handler here, which gets access to the response immediately, so without even the data. So here I'm adding back a block, and let's take a look at the response here. And also, since we added back the block, we now need to return this explicitly. So again, for now, we are just taking a look at the response object here. And so here it is. And so right here, you can see that the OK property is set to false. And so the reason for that is, of course, this status code 404. Now, when the request goes well, and so that's what's going to happen when I click here. So then if we take a look at the response, OK is true, and that's because status is 200. And so 200 literally stands for OK. So we can now use the fact that this response has the OK property set to false to basically reject the promise ourselves manually. All right? So we can do that by creating a new error. So we can say if there is no response.ok, or in other words, if response.ok is false, then we write throw new error, and then here we can define an error message. So let's write a very logical message here, which is country not found. So this is the real error message that we want to see here, and of course not this one here with cannot read property of undefined. And here we can then also take the status code and display it as well. So this 404 in this case. Let's just wrap it here into parentheses. And okay. So this is something that we never did before. So let's analyze what happens here. So we create the new error by using, again, this constructor function basically. And then we pass in a message, which is going to be the error message. Then we use the throw keyword here, which will immediately terminate the current function. So just like return does it. Now the effect of creating and throwing an error in any of these then methods is that the promise will immediately reject. So basically, the promise returned by this then handler here will be a rejected promise. And that rejection will then propagate all the way down to the catch handler, which we already have set up here. And so now, if we would try to reload this, and actually let's do that. So now this error message that we created here, so that's country not found 404, so exactly this is exactly the rejection that we created here by creating this new error. All right. So again, any error that happens in any of the callback functions here, so in any then handler, will immediately terminate that then handler and will propagate down to the catch method here. And then in there, we handle that error. And so therefore, that's why we then see the error here displayed. So that error.message is exactly that message that we pass into the error here. And in fact, the same is true for any other error. So before we had this, the error that we saw was this one here. And that's because somewhere in the render country function, we are trying to read the flag from the data that we received. But the data that we received did not contain this flag. And so therefore it created this error, and then that error caused the rejection of the promise, which was then one more time handled down here. Okay? So again, any error will cause any promise to reject. But here we are simply creating our own error to basically reject the promise on purpose so that we can then handle that error down here in the chain, so in this catch method. All right, but now you might be wondering, why should we even bother handle all these errors? Isn't that just a bunch of work and a waste of time? Well, first, handling these errors is the only way in which we can actually display an error message like this on the screen for the user. But even more important, it's just a really bad practice to leave these rejected promises like hanging around without handling them. So don't do that. Always use catch, and if necessary, you can also use finally. Okay. And now, again, what if there was no error here in this promise? So if we got no problem in this one here, but then we got a problem in the second fetch. So let's say that we don't do this, and so we have a reasonable country, which is Portugal, when we click on the button. But then here, let's say that the neighbor is not this one, but this country code, which I'm sure does not exist. And so now there is going to be a rejection in this promise, right? So we get another error here. In this case, it's a 400 error, which means something else. But in any case, the error is not handled. So we now need to go ahead and copy this code here also into this then handler. Let's actually do that, even though we know it's a bad practice and we need to fix this later. Okay. And so now we get the error message that we want. So again, country not found, and this time with the code 400. But now, of course, we have all this duplicate code here. So we shouldn't have this here. And in fact, even all of this is kind of repetitive. It's really, if you think about it, the same code as this one. And so now I think that it's a good time to actually create ourselves a really nice helper function. And this helper function will wrap up the fetch, the error handling, and also the conversion to JSON. Because in my opinion, it's really a bit cumbersome to having to do all these steps all the time. So having the fetch and then having to convert that response to JSON and only then being able to handle it, right? So instead, we will basically encapsulate all of this here into one nice function. So let's do that. And I'm going to call it getJSON. So basically, because it gets data and it immediately converts it to JSON. Now, what do we need here as parameters? Well, for sure, we need the URL. And so for now, that's okay here. So let's get, or actually we can just write it. So what we want here is fetch, and then the URL that we pass into the function. And then on that, we want to call then, and then basically with all of this. So let's grab it here. And of course, we are missing the callback function itself here. So that should end somewhere here. And, well, apparently it doesn't. Maybe like this. And yes, that's correct. All right. Now, in order to actually make this function here really generic, we do not want to hardcode the error message, but instead we want to pass the message in. So let's say error message, and we can set a nice default value. So let's say something went wrong, which again is very generic. And so here inside of this, we then want